Hello everyone. In today's video we are going to discuss about measures of dispersion. But let us first understand what do we actually mean by measures of dispersion. It basically tells us how much the data is spread. For instance, let me show you a distribution which might look like this. In the other case, let me plot a distribution which looks something like this. So in this case, we say this particular distribution is more spread and this one is less spread or dispersed. So in simple terms, we can say that measure of dispersions tells us how much the data is spread. Let us take some important measures. First one is range. Range is nothing but the maximum value in the data minus the minimum value. Let's take an example where we have around 6 points of data starting from 1, 2, 3, 4, 10 and say 100. In this case, the range, which is the measure of dispersion, is calculated as maximum value, which is 100, minus the minimum value, which is 1. So we say that the data is spread and the range is 99. Let us also quickly discuss what impact the change of scale or origin will have on this particular measure. Let's say we change the scale to 2. So we multiply each observation by 2. We get 4, 6, 8, 20 and 200. And the new range will be 200 minus 2, which is equal to 198. Hence we can say that range is impacted by change of scale. However, let's quickly see what happens if we change the origin. So if we change the origin and add 2 to each value, let's see what we get. So we get 3, 4, 5, 6, 12 and 102. So the range in the new case will be 102 minus 3, which is 99. Hence we can say that change of origin has no impact on range. Let us move ahead and discuss the next measure, which is known as quartile deviation. We already discussed in the previous video what are quartiles. So in this case, quartile deviation is simply calculated as quartile 3 minus quartile 1 divided by 2. Similar to range, this is also impacted by change of scale only. Also, one very important thing to note is that quartile deviation only considers the middle 50% of the data while calculating the dispersion. Let us move ahead and see how mean deviation is calculated and why it is a measure of dispersion. So mean deviation is calculated as 1 upon n summation of fi into xi minus a. A here can be any measure of central tendency. It can be mean, it can be median, or any point A. Now, very important thing to note is, as we discussed earlier, that mean deviation is always minimum around median. So if A is median, then this value is going to be minimum in that case. As you see, mean deviation is ignoring the sign because we are taking the absolute value. Hence, we say that mean deviation at times overestimates the dispersion. Moving ahead, we have root mean square deviation. It is one of the most popularly used measure of dispersion, and we will certainly know why. Another point to note in case of mean deviation is that it uses 100% of data, unlike quartile deviation, which utilizes only 50% of the data. Now let's talk about root mean square deviation. Root mean square deviation is calculated as under root of mean square deviation, which is calculated as 1 upon n summation of fi into xi minus a to the power of 2. Now here again, a can be any point. It can be mean, median, or any point which is considered as a central point A. When A is taken as mean, the root mean square deviation is variance, which is calculated as 1 upon n summation of fi into xi minus x bar, where x bar is your mean. And the root mean square deviation is then known as standard deviation. Root mean square deviation is minimum around mean, as we discussed in case of median, as we discussed in case of mean deviation, which is minimum around median. Similarly, root mean square deviation is minimum around mean. Similar to quartile deviation, root mean square deviation is also impacted by change of scale. So let's say if we change the scale by a factor a, then variance becomes a square sigma square, and standard deviation is a sigma. Now, all the measures that we discussed are absolute measures of dispersion. Now we are going to talk about some relative measures of dispersion. So, it is all the same, however, we are bringing the absolute measures into a relative measure so that it becomes unitless. So, range is nothing but max minus min divided by max plus min. Similarly, coefficient of quartile deviation is calculated as Q3 minus Q1 divided by Q3 plus Q1. In case of mean absolute deviation, it is calculated as mean absolute deviation around point A divided by point A. And coefficient of variation, which is the most important one, which is directly asked in exams, is sigma, which is the standard deviation divided by mean into 100. So it's very important to know that this is directly asked in exams, where you are given some value of sigma, x bar, and you are simply supposed to calculate the coefficient of variation using this formula. That's it for video. If you have any questions, please feel free to ask it in the comment sections. See you in the next one. Bye.